Hey, what's up, everyone? Welcome to Descriptive Chem / Lab Part 5. Today we're going to do a bit of practice. We're going to go over the 2017 local test section for Descriptive Chem / Lab, and that's going to be from questions 7 to 12. So let's get started on problem 7. A white ionic solid is dissolved in water. Addition of a solution of sodium chloride to the solution results in a white precipitate. What was the cation in the original ionic solid? So we're told that we're going to start off with an ionic solid. And so let's say the ionic solid is AB, and it's dissolved in water. So that means it's going to turn into A plus and then B minus. So after we do this, a sodium chloride solution. Sodium chloride is added to the solution. So NaCl is added to the solution, and when this happens, a white precipitate forms. So let's see what compounds can form when NaCl is added to A and B. The compounds that can form are going to be ACl and NAB. It's like a double displacement reaction. And so one of these compounds is going to have to precipitate. First, let's take a look at NAB. If we look at the solubility rules for sodium, they're right here. They're always soluble, and there are no exceptions. So that means whatever B is, it's going to be aqueous, meaning NAB is not going to be the source of our precipitate, and that means ACl is going to be the source of our precipitate. However, which compounds allow for the precipitation of a chloride? If we look at the solubility rules here, chlorides are always soluble unless they're with silver, lead, or mercury. And so the only three things that A can be are going to be silver, lead, and mercury. So which one of these answer choices is silver, lead, or mercury? It's going to be C, which is silver. And we are correct. Let's go on to problem 8. An element is a solid at room temperature but soft enough to be cut with an ordinary knife. When placed in water, the element reacts violently. What element is it? So let's go through the answer choices and see which one of these elements are going to react violently in water. So sodium is going to react violently in water. You can see it's one of the most reactive elements. So sodium does make sense. Magnesium is kind of reactive, but not really reactive with water. So it can't be magnesium. Copper is all the way down here. Copper is not going to react very violently. And then mercury is even lower than that. So that can't be it. And so the only answer choice that makes sense is going to be A, sodium. And we are correct. Let's go on to problem 9. A 0.1 molar solution of which salt is the most basic? So remember, in order to do these salt acidity questions, you should first figure out the reactants that produce that salt, and then look at the properties of those reactants. So first of all, let's take a look at A, NaNO3. And so the reactants that are going to form this are going to be NaOH and HNO3. NaOH is a strong base, Sb, and then HNO3, nitric acid, is going to be a strong acid. And so a strong base and a strong acid is going to be neutral. So the salt is going to be neutral and therefore not basic, so A cannot be the right answer. Let's take a look at NaClO4. It's going to be NaOH and HClO4. Again, strong base and then strong acid, and that's going to be neutral. So it cannot be B. NaHSO4, again, NaOH, and then H2SO4. So strong base, and then strong acid, neutral. So by default, the answer has to be D, but let's take a look at proving it. So we have NaHCO3. That's going to produce it's going to be, the reactants are going to be NaOH and then H2CO3. And so NaOH is a strong base, but H2CO3 is going to be a weak acid. And so a strong base and a weak acid means you're going to have a basic solution. And so the answer has to be D. And we are correct. Let's go on to problem 10. Addition of small amounts of which solids to hydrochloric acid will result in gas evolution. Well, first let's take a look at zinc, right? So if we add zinc to hydrochloric acid, Well, it's going to be a single displacement reaction, so we're going to have H2 plus zinc chloride. And so we have the H2. If you're wondering why it's H2, well, if you had H on its own, like H, Z, N, Cl, that wouldn't make sense because hydrogen is always diatomic, meaning it never exists singly, it always exists diatomically. And the diatomic form of hydrogen is going to be a gas at standard conditions. And so that means we do have a gas evolution that occurs. So 1 definitely works. Let's take a look at Na2SO3. So if you have HCl, my bad, that's NCl, what? Okay, HCl, and then we add Na2SO3. Well, what's going to form, again, double displacement reaction, we're going to have NaCl plus H2SO3. However, you should remember that H2SO3 is one of those intermediates. So it's going to break down into H2O and then SO2, sulfur dioxide. And then the sulfur dioxide here is a gas. So that means if we add Na2SO3, we're going to produce this at first, but again, it's going to break down into water and sulfur dioxide. And sulfur dioxide is a gas, meaning you do have a gas evolution in that too. So the answer would have to be C, both 1 and 2. And we are correct. Let's move on to question 11. A student determines the acetic acid concentration of a sample of distilled vinegar by titration of 25 ml of the vinegar with standardized sodium hydroxide solution using phenolphthalein as an indicator. Which error will give an acetic acid content for the vinegar that is too low? And so if you got that the acetic acid content of the vinegar is too low, then that means your reaction has completed before it should. And so which one of these answer choices show that the reaction finished before it really should? Whoa. Okay, so if you get that the acetic acid content for the vinegar is too low, then that means your reaction has finished before you expect. And so which one of these is going to show that the reaction has occurred too fast? Let's go through it. So A, some of the vinegar is spilled when being transferred from the volumetric flask to the titration flask. This does make sense, because if there is less vinegar, then that means the reaction doesn't have to do as much. The reaction will finish faster because there are going to be less reactants. And so A does make sense. Let's look at B. The NaOH solution is allowed to stand for a prolonged period after standardized and absorbs carbon dioxide from the air. That just doesn't make sense. It's one of those nonsense answers. The endpoint is recorded when the solution turns dark red instead of faint pink. So dark red means that you've added too much sodium hydroxide. And so that would have the opposite effect of what we want. That would make it seem as if the reaction happened longer than we want. And so that's the complete opposite, it can't be C. D, the vinegar is diluted with distilled water in the titration flask before the NaOH solution is added. The problem with this answer is that a dilution changes concentration but does not change the number of moles in the solution. So the reaction would still occur and it would still end at the same time, because you would still need the same amount of vinegar to react with the sodium hydroxide. And so while D seems like a tempting answer, it can't be the right answer, meaning A has to be the only right answer. And that is the answer. Let's go on to the last one, problem 12. Which piece of equipment would give the most precise delivery of 25 ml of a solution? Well, first of all, you have to remember that B and C are not volumetric glassware. These are syringes and beakers, and they have a certain amount of error percentage that is a bit too high for like a precise delivery. And so the only thing that we're left with is a graduated cylinder or a volumetric pipette. And I guess they would both work, but the volumetric pipette is usually more precise than a graduated cylinder, and that's why it's better to use a volumetric pipette, since graduated cylinders are not, as accurate as volumetric pipettes. So that means our answer is going to be D. All right, that's all I have. It was just like a short little review of the 2017 lab section, and this marks the end of our second unit of descriptive chemistry slash lab. I hope you learned something, and I'll see you later.